Hi, it's Ted Ritzer, host of the Greening Government Webinar Speaker Series. It is a collaboration between my department, Alberta Environment and Parks, the Alberta Climate Change Office, and the Municipal Climate Change Action Centre. And the goals of the series are to help governments in Alberta reduce their carbon footprint as well as grow their green economies. The way the format of the presentations works is we have up to a maximum of 40 minutes presentation followed by Q&As, and I'd encourage webinar participants to start thinking about questions you may want to pose to our speaker. We're very fortunate today to be joined by Sri Ilaprolu of Amazon AWS global lead on the Internet of Things. And Sri, when I started kind of researching, as I was researching this series, I kept kind of finding different administrations. And to give you an example, the London Transit Authority, the Singapore Transit Authority, and also the Chicago Transit Authority, what they all had in common was they used AWS and they pushed their data into the cloud. And then what was really interesting and directly relevant to this whole idea of growing green economies was they opened that data up to local developers who did some really interesting things in the use of that transit data. So on that note, it's just wonderful to have you present on smart cities and the use of AWS and the cloud to support that and to help us understand how the Internet of Things can support the delivery of public services. So with that note, I'll turn it over to Sri. Thanks so much.
Great. Thanks, Ted. Hope you guys can hear me okay. I am, like Ted said, I'm Sri Ilaprolu, part of AWS Public Sector team. I'm joining you guys today from Washington, D.C. on our east coast of the U.S. That's where I'm based out of. So today what I want to do is I have a presentation that I'm going to go through, so let me just go ahead and pull it up. And then once I get that up, I'm going to walk you through what I would call almost like a story. I want to start with, for those of you that may not be familiar with AWS and what we do, the services that we offer to customers. So I want to walk you through some of that and then go on to smart city solutions. So how are customers leveraging us? What are some interesting use cases that we are seeing in the market space? And leave you with some thoughts on what are some interesting things that perhaps you guys can go back to your teams and talk about and see if they're of interest for you to continue on. So with that, let me go ahead and move on. So most folks that I've talked to have familiarity with Amazon, the retail giant. We have been in business for about 22 years now. Most customers and most people that I talk to understand the retail side of it. They recognize the brand, and it's a very well-known, well-established brand. Something that very few people know is that there are other lines of business within Amazon that are also quite popular. So for example, we have a line of business on the devices side where, for example, we make Kindle tablets, mobile phones, television, Fire TV, Fire Stick, Echo, which is more of the voice recognition service-based device that we have recently launched. So there is a full-blown practice that addresses the device side of the house. Then there is the media side, where we produce a number of, for example, movies, game shows, TV series, etc., that are coming out of Amazon Studios. The last piece here is web services, and that's the team that I'm part of. Web services is a business that we launched back in 2006, so roughly about 11 years old now. A simple way to think about it is this is cloud computing. This is the part of the company that focuses on cloud computing services and offering those services to customers across the globe. So another question that I commonly get when I'm talking to audience is, we understand your retail roots. We know what that business is all about, but how did you guys get into cloud computing? So I thought best way to explain this is using pictures. So on the left-hand side is one of our images of one of our fulfillment centers. As you'll see, lots of boxes that we ship to customers based on orders, etc. And on the right-hand side is an image of a data center, for example. Well, if you step back and look at it, Amazon is a retail business, and there are lots and lots of technology services that are leveraged in order for us to fulfill, securely capturing orders from customers, being able to fulfill those orders using logistics worldwide, global logistics, and making sure that our support systems are all secure, safe, and cost-effective. So a lot of innovation and IT experience has been built up internally, and over time, we have realized that that became a core competency of the company. We also realized at the same time that a lot of other companies in the industry of every segment were looking for that kind of experience and services that they can also leverage that we have been able to amass on our side. So back in 2006, we launched AWS, taking some of that experience as well as the technology building blocks, and launched external facing cloud computing services. And that's how the business started back in 2006, and we're going on 11 years now. So what are we doing? What do we provide? We provide another way to think about cloud computing, and what we provide is reliable, cost-effective services that you can access, anyone can access in the cloud, being able to spin things up at a moment's notice, shut things down when you don't need them, only paying for what you actually need and use, and doing all of this in a very secure, cost-effective way. And that has been a game changer for a lot of companies, initially startups, but then since then, public sector organizations around the globe, enterprise customers around the globe have been started leveraging, and more companies are moving what we call all in, which means they're in the process of shutting down entire sets of data centers around the globe and moving completely into AWS, and AWS becomes their virtual backbone or data center that they're operating out of. So at this point, we've reached over 1 million active customers on a monthly basis, meaning we're serving customers of every shape and size in excess of 1 million in 190 countries, doing different kinds of things on top of the platform. So when I say platform, what do I mean by that? Well, on the slide, you're seeing a full comprehensive set of services that we offer to customers. I won't go through all of the details here, but just wanted to give you a flavor of what do I mean by cloud or AWS services or infrastructure services. This is what it looks like. Simple way to think about it is anything a customer wants to do or may be doing in their own data center or co-location facility can be done in the cloud more securely in most cases, more cost effectively almost always, and then with a lot of agility that comes in. Like I mentioned, you don't need to pay for things that you don't use. You can spend as many resources as you want for the projects that you need, and then when you're done, turn them off and you stop paying for it. So that kind of agility allows customers to innovate in a very rapid pace. So where are we? We have a concept of what we call regions. And then within a region, there are what we call availability zones. So region, simple way to think, is a cluster. It's a geographic part of the globe where we have a cluster of data centers that we operate. We have 16 such regions around the globe. 2 more planned to be online before end of the year. Out of the 16, we have 5 in the US. And then we have a region that we've recently launched in December, actually, early part of December of 2016, in Montreal, Canada. Each one of our regions has multiple availability zones. An availability zone is a logical grouping of data centers that are very close to each other. And like I said, each region has at least 2. Many regions have more than 2 availability zones. And the availability zones themselves are completely fault isolated from each other. So think of different part of the power supply grid, different backup heating, cooling systems, different tier 1 ISPs serving, different fault lines, flood plains. The goal being that we want to isolate faults in infrastructure, IT infrastructure space, where if an AZ gets impacted, other AZs in the region are completely isolated from that fault, whatever that fault happens to be. So that's the goal, and that's how customers are able to build highly reliable systems within a region or leveraging multiple regions as needs dictate, but then not have to worry about paying for all of that when they don't necessarily need to. Another point I want to make here is a region is a completely isolated portion of the infrastructure or a cloud. Another definition that I've also seen is while we call AWS Cloud and 16 regions, some customers have referred to it as 16 clouds that make up the broader AWS Cloud. Each region is completely isolated from a privacy, from a data movement perspective. When you store data in a particular region, when you launch applications in a region, that's where it lives. We do not move it out of the region. You have the flexibility to move it, but it's up to you if your application needs dictate for you to move it out of the region. This is interesting and very important because it allows public sector customers, especially that are subject to government requirements, to comply with local laws and policies. In addition to regions and availability zones, we also have, as noted here, 68 edge locations around the globe. Edge locations are our points of presence around the globe so that we can deliver content to customers in a much better latency, reducing the latency in delivering the content. Another interesting thing with AWS is what customers are getting with the platform is not a static platform. We are continuously evaluating, innovating on top of the platform based on customer needs and based on what we hear from customers. And we're adding new features almost daily. Last year alone, we've added, as you can see on the screen, over 1,000 features. That translates to over 3 net new features of significance every single day of the year. What this means is customers have access to these new features as soon as we add them. Some of these are automatically added. If it's a security or an operational benefit, we're automatically taking care of them. But other features are available to customers so that they can adopt those features if it makes sense for their use cases or solution. Gartner does industry analysis, and they've been doing cloud infrastructure as a service analysis for over 4 years now. AWS has been positioned in the leader quadrant right from the day one, and we continue to be in the leader quadrant, both from a ability for execution as well as completeness of vision. Showing that we can operate at a very high scale and very reliably and deliver services, but also the vision that we have both for today's needs as well as looking into the future and meeting the needs that customers may have in the future. Compliance and security obviously is a very important topic that customers bring up. So I wanted to cover this, which is our services have been architected and built in a way that allows customers to comply with a variety of security compliance regimes that may be in place. These are some of the ones that we have been able to comply with so far. Compliance and security are absolutely key for us because, as you can imagine, if customers are trusting their data and their solutions and applications on top of the platform, we need to make sure that it's secure. Customers are able to comply with whatever policies they need to comply with. So this is something that we absolutely keep on top of. And as more and more compliance regimes come on board, we make sure that we're addressing those needs as well. In this public sector space alone, I mentioned earlier, we are supporting over 1 million active customers worldwide. But taking a look at the public sector segment, we are now supporting 2,300 plus government agencies worldwide. We're over 7,000 educational institutions around the globe and over 22,000 not-for-profit institutions leveraging our services for a variety of needs around the globe. And these numbers are going to keep going up as more and more customers see the benefit of what other customers may be doing and start adopting the services for their own needs. I wanted to quickly highlight some customers. I mentioned earlier that we launched our AWS region in Montreal in December of 2016, roughly about 4 months ago. We've already seen a lot of customer adoption in Canada. And in fact, I should say that a lot of customers were using AWS services in other regions from Canada well before we've launched our AWS region. Once we launched in Montreal, the pace of adoption has increased significantly. And these are some customers that have started talking publicly about their use of AWS. For those of you that may be familiar with Desire to Learn, which is a educational technology company based out of the Toronto Kitchener area, they're a global company. They have customers around the globe, and they have moved. They're in the process of moving completely out of all of their data centers that they were operating around the globe and into an AWS platform, and that gives them ability to scale around as needed and be very cost effective and secure at the same time. One of the questions that we also get as we start expanding our footprint around the globe, and I mentioned earlier, we have 16 regions now, 2 more to come online by end of the year. That will take us to 18 regions with lots of data centers aggregate. One of the questions that we get is, what are you guys doing when it comes to green energy, renewable, and sustainability? So in 2014, late 2014, we've declared publicly that we have a long-term commitment where we want to be 100% renewable energy based. All of our data centers and infrastructure facilities will operate on renewable energy. Yeah, I'm glad to say that by end of 2016, we had a goal of coming close to 40%, and we have actually exceeded that goal at the end of 2016. We've set a new goal for end of 2017 to be at 50% based on renewable energy for all of our data centers around the globe. And not just relying on energy sources, renewable sources that the local countries and geographies may be able to support, we've actually taken a proactive step and launched a number of projects so far, both in the solar space as well as wind farms, primarily here in the US, and we're starting to evaluate other areas as well. The goal being that we want to supplement and we want to actually create more energy that's based on renewable source that perhaps will be able to feed into our own data centers and our own needs. As you can see on the screen, number of projects that have gone live and many more that are planned and will be coming online. If you add up all of those, we expect 907 megawatts of renewable energy to be generated out of those projects that will be able to serve AWS needs. And as you can also see, 2.6 million watt hours of energy that's being produced annually that's based on renewable sources. Last point I want to touch on this is there's also questions that we get from customers as to how does it help if I have sustainability goals or energy efficiency goals? How does it help if I were to consider moving to the cloud, or does it help? The answer is absolutely. Cloud by definition is pooling resources and using the resources in the best possible way, allowing customers to get much better efficiencies out of the infrastructure that we're operating. So there's the way we convey that, it's greener in the cloud. By operating in leveraging cloud resources, you're not wasting resources, you're paying for what you use, and we are operationally optimizing the use of those resources so that the overall benefit to the aggregate number of customers on top of the cloud is quite high. There are carbon neutral options already available. The point I want to draw here is Montreal region I mentioned we launched in December is already 100% carbon neutral. And we have additional regions around the globe that customers, if they have needs that need to be carbon neutral, they can start out in one of these regions. And hopefully as we make progress on our renewable energy goals, we'll be able to meet more and more regions into this mix. With that context and background, I want to go towards smart cities, the topic of today's discussion. There is a URL on the screen, and I'll make sure that you have access to this as well later on. That has a lot of information that I may or may not be able to cover in today's session. If you're interested, certainly feel free to browse that. And if you have any questions, contact us. So when we talk to cities about smart city solutions, some of you may know this already, others this may be the first time. One of the things that we find is that there is no single area within a city or a local government or a state or a country in some cases that is the only area where technology can help and actually benefit citizens and operationally and cost effectiveness for the city officials themselves. So when we talk smart city solutions, they are spanning and covering all areas and all operational spaces within a city or a state or a country. There are some popular use cases that start to bubble up. These are some of the ones. There are many more, but fleet management, being able to sensorize and use data appropriately to make sure that my transit systems, my bus systems, my rail systems are operating properly. I'm making that data available to citizens so that they know what the wait times are, for example, how long is it going to take to get to my next stop, or things like the maintenance history and operationally ensuring that the fleets are fully managed and maintained well is a very, very good example of a use case. Transportation tends to be quite popular as well. And in fact, I'll cover some of the use cases that will touch on transportation specifically. Energy efficiency, you hear the terms smart buildings, green buildings, and similar terms. Most of those are talking about how do I use sensors and be able to use the data that those sensors are capturing in order to ensure that I'm consuming less energy, yet providing the same benefits, or in some cases actually better environmental conditions within a building. A building could be a small apartment, or it could be a large commercial space where energy consumption tends to be quite high. And then moving on, there are a number of other things like waste management, safety-related solutions, as well as more civic engagement type of use cases that we also run into. When we step back and look at it, when someone says, I want a smart city solution, or I want my city to become smart, what they're really talking about and what they're expecting to do is they want to be able to look at the data, whether it's data that already exists in their own internal systems, or perhaps systems that they may be using already, or they want to start adding additional data sources such as sensors, by being able to deploy sensors, being able to leverage data that exists in the open space, like for example, weather data or traffic data or any other data source that exists in the open data space, be able to pull all of that in, analyze that data for basically based on the use case or the needs that the city has, and then make decisions appropriately so that you're able to optimize resources, you're able to lower energy consumption, as an example, or you're able to lower cost of operations, and at the same time provide more richer, better services and make them available to citizens effectively. That's really all. When someone says smart cities or smart city solutions, that's really what they're talking about. So how does cloud play into this? As you can imagine, collecting and dealing with existing internal IT systems is challenge alone. When you add all of these data sources, and now you're talking about lots of data that you're aggregating and collecting, how do you store it cost effectively? How do you compute and analyze that data cost effectively and securely? And how do you do all of this in a rapid manner, as opposed to batching things and sending it offline or offsite for a vendor to process? That's really where cloud-based services actually provide a lot of agility and benefits. And we're seeing customers around the globe start leveraging cloud for these types of projects. There are lots of technology services that customers will also need, whether it's just purely storing the data or analyzing the data, and more recently looking at machine learning or artificial intelligence and IoT as being mechanisms that customers can use to capture more data in a very time-sensitive manner, analyze the data, and rather than just looking at the data that they have captured and drawing insights from it, start predicting things as to where things will go or how things may act or behave in the future or in the near future, so that they can make adjustments to perhaps improve things in that space. And that's really where we see AWS providing a comprehensive platform that customers are able to leverage and stitch based on what their needs are, as opposed to a black box that we may be dropping and saying, this is the platform, this is how you use it. Instead, customers have the freedom to pick and choose whatever services that they need and stitch them together to make a solution that's very complex, yet appropriate for their needs. I want to quickly glance through a couple of services here. AWS IoT, which is our IoT service. This is a fully managed service in the cloud. Customers can point any and all devices to our IoT service. Data is exchanged very securely in a very trusted manner. And you have lots of capabilities within the IoT service itself, where you're able to analyze data real time as it's coming in. You're able to apply rules on it real time. You're then able to pass it on to, for example, more advanced processing, whether it's machine learning, whether it's MapReduce type of functions and other deeper analytics capabilities that you have the freedom to do. At the same time, you're able to send instructions back to those things or devices or buildings, whatever you want to call them, whatever it is that you're connecting in a connected solution, instructions to change things. It's a really simple example. Let's say you're monitoring temperature in a room of your building. And as that data is coming in, maybe you defined a rule in the IoT service saying, if the temperature is more than 65 degrees, go ahead and turn the AC unit on in that room. So all of that could be completely automated and done in a very secure, cost-effective way. That's in a very high-level view. What AWS IoT does is it removes the burden from customers and lets them focus more on solutions and the benefits that they're trying to derive, as opposed to worrying about the technology building blocks. Security has been a focus from day one. Freedom to customers in terms of what kind of devices, what operating systems, all of that is absolutely up to the customer to decide. We also have the concept of cost following the usage, which means as and when you use, similar to all of our other services, you only pay for what you use. If you're not using the service because there is no need, you don't pay anything in terms of AWS IoT costs. Greengrass is another service that I want to quickly touch before I actually move on to the use cases and interesting stories that customers that we're seeing around the globe. Greengrass is another service that we launched where there may be situations, especially in IoT scenarios, where you may not be able to move, even though you're capturing data in the field. In some cases, you may not be able to move it to the cloud for processing. Good example is either you have lack of connectivity or bandwidth is too expensive, or you have situations where you need to react in a very rapid manner to things that are changing locally. So with Greengrass, what you're able to do is take some of that same processing capability and other features that I talked about with IoT service and be able to deploy that on your own hardware, in some cases on the actual device itself, and get those same benefits. And now, even if you don't have connectivity to the cloud, or even if you want that execution to happen locally, you're absolutely able to do that locally. And then when there is connectivity, you can use cloud as the brains for deeper analytics. So quick summary there, you're able to respond locally to the events. Even if you get cut off from the internet or connectivity to the cloud, you can still operate completely as if nothing has changed. And then because you're not moving a lot of data up and down to the cloud, you can reduce the overall cost of your IoT solution. So let me pivot and talk a little bit about customer stories, that early adoption that we're seeing in the customer space. This is an interesting example. This is a project called Pnut Jakarta. It actually changed names recently. The reason why it's called Pnut Jakarta is it's focused on Jakarta, Indonesia. That's where the project started. The use case is Jakarta and Indonesia in general and Southeast Asia is subject to flooding in the monsoon season. And what this project is aiming to do is take advantage of the data that they maybe already have access to and add sensors to detect possible flooding conditions and start predicting where flooding will happen, and do this in a completely automated way so that the local emergency officials have advance notice so that they can position their own assets appropriately, alert citizens so that they know how to, for example, save lives as well as save property as needed, and then do all of that in a more guided way where rather than just blanket warning to the entire city, start predicting as to where things can go wrong and where they're seeing conditions that go wrong. This is also an interesting use case I mentioned where the project is able to tap into data, where all of you probably can appreciate this, where all of us are on smartphones or smart devices of some kind. Most of us tend to be on Twitter or Facebook or some kind of a social media channel. In this example, if let's say there is a flooding happening in one part of the city, Twitter, they have a specific handle on Twitter that people can tweet to. And as data starts coming in, there's a bot that has been written, Twitter bot, that collects all of the data, pumps into AWS. In addition to that, they've deployed water sensing devices that detect actual water levels at, let's say, lakes and rivers and ponds. So they're actually able to see how the water levels are increasing or decreasing. And then when you combine those two data sources and you're getting that real time, you're now able to see, is this a condition of potential flooding situation? And if so, because you have multiple data points from multiple parts of the city, you're also able to predict as to where the flooding is about to happen. So really interesting use case, very good use of cloud resources. Like I said, if they don't, this is something that would have taken a lot of effort to stand up. Because of cloud resources, they've been able to stand this up in a very low cost manner. The project has been quite successful, and they're now expanding it to 3 cities within Indonesia, as well as they have requests from other countries within Asia Pacific or Southeast Asia, where they're planning to expand this eventually too. The next one is out of Chicago. Chicago, as you can imagine, being quite a bit of big city, has lots of moving parts and lots of IT systems and data sources, both that they're collecting as well as data sources that they have access to. When I refer to a data source, I'm talking about things like, let's say, weather data, or it's public works types of data sources, or it's the traffic and transit system type data sources, etc. City has been collecting all of that. They have been crunching through all of that. And what they ended up deciding with the project called Open Grid is they've built a system on top of AWS that crunches through all of the data and makes some of that data available to citizens in a easy to use map-based site, for example, that I can go to. And if I'm interested in, let's say, trash pickup on a particular street, I can click and start getting details as to when is the next trash pickup and what can you expect from a timing perspective, etc. So that's a simple use case, but it's very very powerful in that city has been able to take the data that they were storing and processing and holding internally, turn it around and make it actually useful to the citizens in a much, much efficient and better way. The project has been quite successful that so successful that other cities have approached them. So what Chicago also did is taking that project and creating an open source version of it and making that available to any city that wants on top of AWS through what's called AWS Marketplace, so that any city around the globe that wants it can go to AWS Marketplace with few clicks, launch that entire system in their own AWS account, and start feeding data into it. It's gotten a lot of attention in that regard. Next one is out of Singapore. Singapore Land Transit Authority is responsible for all movement that happens within Singapore. It's the traffic management. One way to think about it is it's a single unit or entity that's responsible for bus systems, transit systems, taxi systems, waterways, etc. Lots of data points that they're collecting. So all of that data gets pumped into AWS, processed on top of AWS, and they're able to respond to needs of the citizens, as you can see on the screen there, with a very low latency and very timely manner. Next one is out of Boston, a project called Street Pump. This is really interesting use case, very simple use case, but quite powerful in the results that it is providing. So once again, going back to that notion of every one of us is carrying one or in some cases multiple smart devices. So what the city has decided is, creative idea is, what if we're able to capture when I'm driving in the city of Boston, and let's say I am on the road, I hit a ditch and my car vibrates, and so does my smartphone. What if there is a data point that can be captured at that point that includes geo coordinates of where that bump is, along with the using the accelerometer in the smartphone, how big the bump is based on the movement of the phone, and transmit that into the cloud. And as more and more data points come in indicating that there is a problem at a particular geocode, that's an indication to the city's public works teams that they need to go look at it and fix it before it becomes a bigger problem. This is where crowdsourcing the data using citizens' daily movement and doing it a completely anonymous way, that therefore there is no personal information that's being moved to the cloud. Yet, city is able to get the benefits of identifying where the problems are and being able to address that in a timely manner. Quite interesting and powerful. Next one is out of UK called, this is City of Peterborough City Council, where they've used AWS as what I call a data lake. What I mean by that is city already has a number of systems that they have access to that they're using. They're collecting a lot of data. They're also deploying smart energy meters in people's homes. So those meters are collecting a lot of data as well, these IoT devices. And they're using AWS to bring data sources from multiple locations, their own internal systems, data sources that are IoT devices that are transmitting data, as well as other SaaS applications that the council is using, pulling all of that data into the cloud and analyzing that data in a secure way so that they can make plans for the future as to what kind of projects they need to be working on to improve cost effectiveness and provide better services to this council. Next one is out of City of Denver. Similar concept of building a data lake on top of AWS, where they're able to pull data from multiple sources and analyze the data. This is also interesting and very specific to smart cities, because one of the notions, one of the talk tracks that you'll hear from cities is, I'm deploying a solution X, like for example, lighting, smart lighting solution, or I'm deploying a smart traffic management solution. Those are what we call, or what we refer to as silo systems or point systems, where they'll provide the benefit of whatever it is that they're trying to do. However, if the city is able to integrate those systems in the background, and now I'm able to use data, useful data from multiple systems and use that in a much more compounded way. A good example is, let's say it's about to rain, so I have weather data coming in. Based on the weather predictions, I predict that it's about to rain, and using that data and changing my traffic flow and detecting the traffic flow patterns, maybe I need to alert my emergency response teams, or maybe I need to position appropriate assets to make sure that the traffic conditions or traffic jams are eliminated as much as possible. So individual systems may not be able to give you that kind of view, whereas when you start integrating systems in the background, that's when you get a much bigger holistic view of how things are happening within the city and be able to make positive changes. Transport for London is another example. Similar to Chicago, London's team was dealing with lots and lots of data sources. And as you can see on the screen, London TfL is responsible for any and all movements in the public sector space that happens within the city. And what they did is collect the data, analyze the data, use it for their own needs, but then also put a portion of that data as part of the open data program and made that data available to startups, developers, and anyone that wants to get at it, so that they can build their own applications, innovative, creative applications on top of it. Lots of interesting use cases and solutions that have come out of this. If you're interested, certainly search TfL AWS and you'll be able to look and read through that as well. Vision Zero is a program out of New York City. This is, the idea here is that New York City Department of Transportation was trying to understand where and how issues are propping up from accidents or traffic incidents or any type of injuries within the city of New York City, so that the goal being that they can make plans in the future to reduce that to almost zero or get to zero. So that's the name, Vision Zero. The way they've been able to start implementing this on AWS is, as you get more and more data, aggregate all of that data in the cloud, no matter where it's coming from, how fast it's coming from, and we analyze it, but also display it out to the citizens in a map format, as you can see on the screen, so that if I am trying to get to a particular part of the city, I can quickly go to the map, I can see exactly which streets are a little bit prone to issues or incidents, and either avoid them or perhaps be careful as I'm driving through. This information is also used by the city itself, so that as they're making plans for, let's say, shutting streets for a variety of reasons, or they're planning to expand, add lanes, this information is quite helpful for them because they can then use that to make sure that the planning process for the future is taking previous data that they're collecting and with the goal of reducing fatalities and incidents on the streets to zero. So with that background, I want to pivot a little bit more where, as you've heard, lots of interesting use cases, but one thing that becomes very clear is when you're talking about IoT, partners and partner-based solutions become very critical. Not every customer is going to build everything from scratch. And in fact, it's probably not advisable that every customer start building everything from scratch. And this is where partnerships become very critical, and AWS has been working with partners around the globe in a variety of use cases and segments to make sure that our customers, when they have a particular need, we have the ability to pull together the best of breed and offer and help the customer in the best possible way. A couple of other services that I want to touch, and I'll pause at that point to see if there are any questions or comments. One of the interesting, and some of you may be aware of this, Amazon Alexa, which is a voice-enabled service that has gotten a lot of attention in the press these days in the last year and a half or so since we went live. Over 10,000 skills. Those are interactions that I can have with Alexa voice service. It has become so popular that a lot of the customers have come back and said, can you offer that similar capability, but let me incorporate that into my own applications, whether it's a mobile app or a web app or any other app that I have, so that I can build conversational, voice-based conversational systems that my citizens or my users can interact with. That's what Amazon Lex and Amazon Polly do. They're voice-based services that customers are now incorporating them into their own IoT solutions or smart city solutions, so that instead of me going and touching something, I can actually speak to a device of some sort and use my voice as a mechanism to interact with the IT system. Recognition is another example where being able to look at an image and start detecting things and actually recognizing things is being leveraged in a very interesting way, where I'm able to, for example, if I can do similarity, or if I'm able to compare objects and give you in an automated way an accuracy level or a predictable level, it's opening up a lot of interesting use cases, whether it's in the public safety and security space, or simple things like entry into buildings, or being able to detect in an automated way where if I'm not able to see who's behind the door or behind the building, using a camera, capturing an image, processing it, and actually providing me information so that I know who's behind the door that I'm unable to see beyond. Skip that. Alexa, I mentioned, is a voice service that we have launched. We're also seeing interesting areas where customers are incorporating both Alexa and our IoT platform together, so that not only am I doing let's say, a building automation system or a building energy efficiency system, but I'm also allowing my tenants to use their voice to interact with that system. A really good example, if you're used to or familiar with Nest thermostats, you can go touch the thermostat on the wall and adjust it. However, what Alexa will allow you to do is not even bother. Use your voice to ask Alexa to turn temperature in my bedroom to 65 degrees, right? So that's a round trip command that's happening through the IoT service, through AWS Cloud, and coming back and letting you control the device that may be in the same room, or perhaps on the other side of the globe. So interesting use cases that we're seeing where voice and sensors and devices are being incorporated into more solutions that are being built to address smart city use cases. I mentioned earlier, partners are absolutely critical. We have a number of partner platforms that are already available for customers to leverage. We're also serving a number of customers using solutions that they can adopt and implement on their own. One particular mention that I'll make a note here is MyVision is based out of Toronto. They're a traffic management solution, intelligent traffic management solution that can be leveraged for controlling traffic and monitoring traffic flow within a city. Last point I want to mention here is smart cities. We have launched a program or a global challenge called City on a Cloud, AWS City on a Cloud. This is our 4th year, where any city or any government entity, public sector organization can apply. There are 3 different categories where if you're already doing things on AWS and you want to share your best practices with others, you can apply and get, if you win that, you get access to AWS services. You can also apply under Dream Big category, where you have an idea that you're trying to incorporate, and it would be helpful if there are AWS services that are made available. That's certainly a category that you can consider, as well as there is a category specifically meant for partners that are innovating on behalf of state and local government customers and creating innovative solutions. So something you may be interested in checking out. The contest closes on May 12th, I believe. So if you have anyone that's interested in that, certainly encourage them to take a look at that. So with that, I want to pause and see if there are any questions, any comments.
So maybe if you could help us kind of think about sort of how would folks get started? How would they get going? The initial conversation.
Yeah. So, I mean, I went through a lot just to give you a flavor of what is happening around the globe, as well as the capabilities from an AWS services point of view as to what's available. What I would recommend and what I've seen as our teams start working with customers and cities around the globe is prioritization. I mentioned earlier that when you talk to a city about smart city solutions, it's a wide open space. There are lots of things that could be done. So picking and choosing as to where do you want to focus to get the early learnings, experience, and perhaps get the early results that will help you think about rolling more and more solutions down the road. There are certain areas that I've seen bubble up based on the city's priorities. For example, transportation tends to be an area that a lot of cities are very focused on. Obviously, the bigger the city, the more traffic and transportation related issues they're dealing with, and therefore it's a much bigger priority for them. In other cases, I've seen public safety becoming a priority for some customers as well. So that's certainly an area that they may be interested in exploring. And we have a number of solution providers that operate on top of AWS that provide solutions like being able to detect a gunshot as soon as it is fired anywhere in the city using acoustic receivers that are placed on top of a few buildings, and being able to triangulate it precisely as to where that gun was fired so that emergency response teams can respond in a matter of minutes, right? Solutions like that. So depending on what the priorities are for the city, whether it's transportation, public safety, public health is another one that is quite interesting and popular as well. And then last but not least is efficiencies, energy efficiencies. It's things like waste management. It's other types of services that cities provide to citizens, being able to optimize and operationalize and cost-effective ways of doing things. So I would say, looking back, based on the city that you are part of and what your priorities are you more interested in transportation challenges? Are you more interested in energy efficiency as an initial project? Narrow it down. Certainly reach out to our teams or anyone that has experience dealing with smart city solutions and work through a plan. And we can certainly bring in our partners into that discussion so that you have a start to finish full solution that you could be looking at.
Okay, a question posed for you is, can you touch on the state of development for the standards for the Internet of Things?
So, interesting question. There are certain, I would say, more along policies and regulations and less on standards, in the sense that IoT is nothing in terms of the data movement that's happening, protocols that are used to move data. There are already established standards that most vendors already use. For example, you may be moving data over HTTP protocol. You may be moving over WebSockets. You may be moving over MQTT or AMQP. So the protocols have been established a long time ago, and those are the same protocols that have been proven reliable and safe that are being leveraged in these solutions as well. Then there are things like security of the data that you're capturing, security of the data at rest and in transit. Once again, those things have been solved and addressed in other parts of the use cases that are being leveraged when you're talking about IoT solutions. So with that, I would say from a standards perspective, this is an area that we are continuing to see evolve over time. Perhaps in the future, we'll see new standards coming out. But as of now, more and more customers, especially in the public sector side, are focused on policies so that they can guide their cities saying, what kind of data are you allowed to capture? How do you handle the data? How do you dispose the data? What are some privacy implications associated with the data that you may be collecting, right? So it's more along the policy side of it that we're seeing movement, and not so much on the standards. Once again, because standards are, it's not a brand new area that we're touching on. We're already, we're using or leveraging standards that already exist.
Another question that's posed is related to the security of information, Sri, and guidelines in terms of the housing of public data within Canada.
Right. Yeah. So that's a good question as well. Where typically what has been a misunderstanding is when you place data into AWS cloud, that you do not know where the data is. It could be anywhere around the globe in any of our data centers. That's absolutely not true. I mentioned earlier when I went through the regions and availability zones description that when we launch a region, it contains multiple data centers divided logically into availability zones. And when a customer uses a particular region of AWS, and let's say that's where they're storing the data, and that's where they're deploying their applications, that's exactly where it lives. So while we do not disclose the exact physical address of a particular region, we can guarantee that that data doesn't leave the region unless you move it out of the region. And therefore, if let's say you have data sets in Canada that are subject to Canadian laws and regulations, you can certainly lean on our Montreal region. And if you were to leverage that for storing data or using applications on top of that cloud, that's where it lives. It doesn't automatically move into one of our US regions or other regions around the globe. So that's how you can address regional geographic-based requirements. From a security point of view, lots of capabilities that the platform automatically brings to bear, whether it's things like encryption, automatic encryption at rest, all traffic moving in and out of the cloud tends to be over secure channels by default, so that you're providing security encryption in transit as well as a number of other capabilities that services on AWS offer to customers by literally checking few options as they're starting to load data or start deploying solutions on top of the cloud.
No, that's excellent, Sri. A colleague of mine, Maurice Purnell, is going to join us now. I think Maurice has got a few questions for you.
Okay.
Hi, Sri. Yes, it's incredible the content that you're giving us. You've inundated us with some awesome content. And speaking of inundations, you may remember in the news back in 2013, we had a very serious flood in Calgary, High River, and surrounding area. And I can see a lot of potential for some of these services to be used in that kind of scenario. You may recall in the news last year the wildfire in Fort McMurray, and a few years before that back in Slave Lake. My question is, in Canada, so you gave us a lot of examples, New York, Chicago, et cetera, et cetera. Do we have any smart cities or even semi-smart cities in Canada that we can sort of reach out to and learn from?
So I would say there are discussions underway with customers that are interested in understanding how they can leverage AWS. What I would do is I will get back to you after the call, and once I collect data from our team, after I get a chance to talk to our team to understand who those customers are so that we can connect you with them to interact and talk and discuss what they're planning to do. But going back to your point about fire hazards, flooding, etc. These are some common themes that we are absolutely seeing. These are not city-specific, so to speak. These are much broader than that. And these are some use cases that we're certainly hearing from customers, for example, I mentioned Southeast Asia for flooding as an example. But if you go to Latin America, there's certainly discussions from multiple parts talking about being able to use sensor technology and IoT to capture air quality data and also use sensors for precision agriculture. So being able to predict, being able to capture data and then use that in the cloud to analyze it and then tell where and how much I need to be doing, what I need to be doing in order to increase the yield of the crop. Or early stage discussions also about tremor detection, for example, where sensors that are deployed along the coastline can be used to continuously stream data about any kind of ground movement, and then start using that data and automatically alerting if there is a potential problem. I wouldn't necessarily say that these are fully ready deployed solutions just yet. Lots of discussions underway.
Another person who presented into this series, Sri, that I wanted to ask you a question related was Frank Pace from a university in the Netherlands. And what Frank has collaborated with is a number of police forces throughout Europe. And what they're really interested in using, which I think is, you guys are right in the thick of, is smart devices and building in that the Internet of Things and the GIS into apps for first responders.
Yeah. So we have a number of solutions that are currently in the hands and actually available for customers to consider. I mentioned in the public safety space, I mentioned ShotSpotter, which is a solution that's used for gunshot detections. There's another partner of ours in the space of police body cam solutions, where once again, it's an IoT solution where a body camera that's on the policeman's uniform gets automatically activated based on certain conditions. And then that data is live streamed into the cloud in a secure way, into a secure spot, and then automatically redacted, and lots of other capability that this partner has built called Body Worn, that's also available on top of the cloud and is being deployed in a number of cities around the country and in fact around the globe. So public safety is another area where we're seeing a lot of innovation happening, whether it's on the first responders along fire response or medical response, for example, ambulances and such. And certainly police forces also looking for ways to optimize and automate data capture as much as possible.
Another interesting question related to elaboration on standards is like Apple's HomeKit ecosystem and the Nest ecosystem, they don't integrate very easily. And I imagine this extends to other Internet of Things services. What are your thoughts on the conflict between competition and harmonization in the Internet of Things space?
Yeah, so that's an area that we have very deliberately and very thoughtfully entered into, where our approach is, and this is not that different for IoT. This just amplifies because there are some bad examples out there. But generally speaking, when we think about AWS services, we design and make sure that the services are as interoperable and as flexible and open as they possibly can. Yet, they should be secure, that customers' data and privacy should be automatically secured in as much as possible. So with that in mind, with the IoT specific set of services, I mentioned earlier that we do not necessarily mandate or dictate a particular way of doing things. We are open to industry standards. So for example, if you're sending data back and forth, you can use the industry standard protocols to exchange data with our IoT services. We're not dictating that you have to use a particular standard. There are 3 in particular that have been chosen because of the fact that they happen to be the vast majority of use cases, MQTT, HTTP, and WebSockets. If you're using any of those 3 protocols, you can move data in as well as move data out without any issues with when you're interacting with our services.
Hi, Sri, it's Maurice here again. Ted mentioned climate change before the session started. And you, at the beginning of your session, mentioned renewable energy generation and savings. Do you have stats? And you were sharing Amazon generation and savings. Do you have stats at the federal or state or city level of cities generating and saving energy, similar to Amazon?
Yeah, so I do not have the number myself. We have a team that's focused on sustainability within both internal at AWS as well as also works with customers to help them understand what are some best practices in their own, so that they can achieve their own goals of sustainability from an energy and other types of angles. So what I would do is I will make a note, I will reach out to that team, and I'll try to connect them with your team so that you can go through deep dive and data dives into that.
I've got another question, Sri, and it's related to your example in Boston of using cloud to measure and track potholes. That was very, very impressive then, and a lot of citizens in Edmonton would be really, really happy if we were able to implement something like that. So how long did it take Boston, and how long would it take us if we went down that route to implement even a pilot? Right.
So the way the Boston project went is they've actually implemented through a partner. So if you have somebody that you're working with in, for example, developing a mobile application that knows or has an understanding of AWS already, I would say it's a fairly straightforward, simple project. If the partner that you select for development and deployment happens to be brand new, they're not familiar with AWS, it may take a little longer. So it all depends on the partner's capability that you select to deploy this project. If on the other hand, you want to do it on your own using your own teams, that's another area where it depends on how comfortable you are for your teams to get going on AWS services. And we have teams in Canada that are AWS teams in Canada that can certainly help and guide through the process in, number one, educating your teams or partner teams. Number two, doing architectural reviews as you're planning things and planning to go forward and actually build and deploy. We can provide assistance in architecture reviews and any best practice guidance that we can provide to help your goals be met, and you're doing it in the most secure and cost-effective way.
So let's say, for example, that we've got a small team of 4 really savvy fourth-year engineering students who are up to speed. In an example like Boston, are we talking weeks, months, or years before we have a...
So it's generally in the factor of weeks. Obviously, once the data is being received on the cloud side, depends on what you want to do with it. If it's as simple as collect the data, display it back out to an administrator of some sort so that they have access to the geolocation and where the number of entries that are coming in. If it's as simple as that, I would say it's a matter of weeks. But if you're trying to automate the overall process where you're not only collecting data, you're then making that data automate ticketing systems and submit entries to your public works teams, right? So that's more of integration with other systems. That may take a little longer. But generally speaking, it shouldn't be more than a few weeks.
Well, that's incredible, Shri. I think we're coming to the end of the time where folks, I think, are headed off for lunch. But what I'd like to do is give you the opportunity to give us some parting thoughts, Shri.
No, really appreciate the chance. And like I said, if you guys have any questions, certainly feel free to send me an email. My email is displayed on the screen right now. And if you are interested, if you have any projects that you're interested in talking about, certainly, once again, feel free to contact us. And there's actually a link on the screen right now that you're seeing that connects you to our Canadian team as well as all of the activities that are happening in Canada. So feel free to browse that. And then also mentioned City on a Cloud contest. Feel free, look around and see if you have any customers or perhaps you yourself, if you're in the state and local space, feel free to look through that and see if you are interested in applying for that. So with that, I want to thank you and good day.
Excellent. Well, thanks so much. Okay, take care.
Bye.